My name is Christian Dave Abihar. I-discuss ko yung component ng nuclear power plant. First, we have a containment building along with the steam generators, control rods, uranium fuel, and the reactor vessel. Then connected to the steam lines and turbine. Then after the turbine, we have generator transformer. Then from the underground, we have a pump, condenser, and cooling water to the pump. We have a cooling tower that source cooling water source, and then transformer to the electricity. And this is the visual image that components in nuclear power plant. So next slide. The first component that we have is pressurizer, a component of the primary cooling circuit where the liquid and vapor stages are balanced in condition of saturation so as to control the pressure. So like we said, the pressure is like cooling circuit na nagko-control ng ating pressure and then provides the surge volume for the reactor coolant system. The next is the reactor vessel. Reactor vessel is the vessel that houses the nuclear reactor, the main component of the nuclear power plant, where the fission chain reactor is produced. Its nucleus is composed of the fuel elements. So sinasabi dito na yung containment building is nasa along with reactor vessel. So nag-hold siya ng nuclear fuel when the reactor is operating. So the next component that we have is the fuel, the material where the fusion reaction takes place. The most common material used in enriched uranium oxide. It is the use semi-metallic university as a source of energy and neutron in order to maintain the chain reaction. So sinasabi lang dito na yung fuel is yung ginagamit natin and primary na ginagamit natin dito sa ating nuclear power plant to produce energy and operate the whole power plant nuclear. The next we have is control rods. These are the reactor's control elements acting as neutron absorbents. They are made up of indium, gallium, or boron carbide, which make it possible to control at all times the neutron population and the reactor's reactivity, making it critical during its operation and subcritical during the stop. Dito sa control rods, nag-absorb siya ng neutron and control rods prevent the neutron from causing further fission. So siya yung nagpe-prevent ng mga delikadong fission dun sa mga while nag-operating yung machine and then yung sa power plant. That's all for control rods. The next is vapor generator. Heat commuters where the cooling water from the primary cycle which circulates around the inside of the inverted U-shaped tubes yields its energy to the secondary circuit water and turns it into water vapor. So dito naman sa ating vapor generation, sinasabi dito na siya yung high pressure of the stream exert pressure on the angle base of the turbine. So sa din, nagsasanhi din siya ng mga causing the shaft to rotate. While operating yung nuclear power plant, kailangan natin i-check yung vapor generator like doon sa steam generator na nagpo-produce ng heat. So kailangan natin i-check yun para maiwasan natin yung pag-heat malfunction natin dun sa machine. So next is yung containment building. A building that houses the reactor's cooling system as well as several auxiliary systems. Function and shielding normal operation and prevent the leakage of polluting products to exterior. Dito naman sa containment building, meron siyang glass type well shell or other exclusion around a nuclear reactor to confine fission products that otherwise might be released to the atmosphere in the event of an coincident. Next slide. The next is we have a turbine, a device that receives that water vapor from the vapor generators whose energy is transformed via the paddles into mechanical rotation power. Dito sa ating turbine, kung natin sa nuclear, ang ginagamit sa kanya is yung turbine wind na work. So, simply principle, instead of using electricity to make wind like fan wind, use gumagana yung turbine para magkaroon ng electricity yung mismong nuclear power plant. So the next is alternator, a device that produces electricity by converting mechanical rotation energy from the turbine into medium power and high intensity energy. Dito naman sa alternator natin, nagta-turning yung mechanical energy into electrical energy. So, in short terms, siya yung nagpo-produce ng energy sa mechanical para magkaroon tayo ng electrical energy. Transformer, a device that raises the tension of the electricity produced into the alternator in order to minimize losses during its transport the consumption points. So dito sa transformer, when the alternating current pass through the primary coil, it creates a varying magnetic flux. Sinasabi lang dito yung next sa iba, na yung transformer is yung isang device na nagpo-produce ng electricity through the alternator. So siya din yung nag-minimize ng losses during the transport while dun sa ating consumption points. Okay, the next is cooling tower. Cooling tower, water taken from a river, reservoir, or the sea and used to liquefy the water vapor in the condensator. It can be directly returned to its origin, open cycle, or be reused by the cooling tower closed cycle. Dito sa cooling tower, meron tayong dalawang klaseng sinasabing cooling tower. So the first is open cycle and the closed cycle. Dito sa open cycle, sinasabi din na siya yung nagda-direct return from the origin. And then naman sa closed cycle, from the symbol is siya naman yung nagre-reuse from the cooling tower. So meron dito sa pag-tower, using water to extract waste heat from system and ejecting into the atmosphere primarily through evaporation. So kung nakita natin kanina yung sa visual information, sa visual image, yung source ng water natin is underground. So like the sea, yung mga tubig sa pinakailalim ng ating lupa. So siya yung ating source ng tubig para magkaroon tayo ng evaporation to the cooling tower. The last components that we have is condensator. Heat commuter composed by a set of tubes where cooling water circulates. The water vapor going inside the condensator from the turbine is purified. Dito sa condensator is siya yung nagda-draws energy from the battery and store the energy. Yun ang po at maraming salamat.
My name is Almacenjan Ethan Troy P. and this is Pros and Cons in Nuclear Power Plant. Pro, low carbon. Unlike traditional fossil fuel like coal, nuclear power does not produce greenhouse gas emission like methane and CO2. Nuclear produce roughly the same or less emission as renewable sources, so could be considered an environmentally friendly source of energy. Cons, if it goes wrong. Anti-nuclear campaigners will cite the three major nuclear meltdown of recent times, Three Mile Island in 1979, Chernobyl in 1986, and most recently Fukushima in 2011. Despite all the safety measures in place, these nuclear plants different factors caused them to go into meltdown, which was devastating for the environment and for local inhabitants who had to flee effect mass. Frost, frost, not interminate. Uh, the consistent criticism of renewable energy like wind and solar is that they only produce power when the wind is blowing or the sun is shining. Cons. Nuclear waste. Anti-nuclear environmental group Greenpeace released a report in January 2019 that detailed what it called a nuclear waste crisis for which there is no solution on that horizon. One such solution was a concrete nuclear waste coffin on Ruin Island, which has begun to crack open and potentially release radioactive material. Pro, cheap to run. Nuclear power plants are cheaper to run than their coal or gas rival. It has estimated that even factoring in costs such as managing radioactive fuel and disposal of nuclear plants cost between 30 to 50% of coal plant and 20 to 25 of gas combined cycle plant. The amount of energy produced is also superior to most other forms. The U.S. Department of Energy estimated that to replace a 1 GW nuclear power plant would require 2 GW of coal or 3 GW to 4 GW from renewable sources to generate the same amount of electricity. Cons, expensive to build. The initial cost for building a nuclear power plant are steep, are recently virtual test factor in the US estimated rose to 3.5 billion to 6 billion alongside use extra cost maintain the facility. South Africa SCAPE plans to add 9.6 GW of nuclear power to its energy mix due to cost which has estimated anywhere between 34 to 84 billion. So Will's nuclear plants are cheap to run and produce inexpensive fuel to initial costs.